In this video, we are going to learn about factor theorem. It is nothing but an extension to remainder theorem that we have already studied. Okay. Now, as you can see on my screen, factor theorem is split into two parts because there are two types of questions that exist from it. Okay. The first, when we have factor given to us. Okay. And the second one, when factor is not given. Okay. That means we are just talking about the factor being given or not given. However, the main polynomial for which we need to check is always going to be given to you. Okay. So let's start with the case 1 when factor is given. Okay. Now over here, case 1 says factor is given to us, right? Let's read the question and it says use factor theorem to show that this polynomial is exactly divisible by x plus 3. Okay. As I said, factor theorem is nothing but an extension to the remainder theorem. The only difference in the remainder theorem, they talked about what's going to be the remainder when you are given a polynomial and a factor. Over here in this question, they have given a similar kind of equation, but now they are asking, we need to check if the second expression is a factor of the first expression or not. So just the words are different, but the method and the things are absolutely same. But how we do it? Now, we are going to start with the second polynomial over here, which is x plus 3. Okay, so I will name this as gx equals x plus 3. Now, I'll equate this with 0. That means I am getting the value of x as negative 3, right? This is nothing but my 0. And I need to check if the given polynomial will, this value of x is going to satisfy the given polynomial or not. Okay. So let's start. The first polynomial, I'm naming it as px equals x to the power 4 plus 2x cubed minus 2x squared plus 2x minus 3. Okay. So I will substitute the value of negative 3 over here and let's calculate. We have negative 3 to the power 4 plus 2 times negative 3 to the power cube minus negative 3 square plus 2 times negative 3, and we have negative 3 once more as a constant. Okay, so now we will just start with solving it and it gives us 81. Negative 3 cube is negative 27 times 2 becomes negative 54. Negative 3 square is 9, becomes negative 18. Negative 6, negative 3. Okay. Here we have 81. Now I'm just simplifying all the negative terms first. So we get 54 plus 18. That gives us 72. 72 minus 6, 78. And 78 and 3 is 81. So we are getting 81 minus 81, which is 0. Now, if we have got the value over here as 0, we had already studied in remainder theorem that after substitution, if we are getting a 0, that means the value which we had substituted as negative 3 is the 0 of the polynomial. And if some value is a polynomial, that some value is a 0 of the polynomial, then in that case, the expression x plus 3 is a factor. So after this, we just need to conclude, therefore, x plus 3 is a factor of px. This conclusion is important and mandatory because the question asked to use factor theorem to show. And when they're asking to show, that means you need to conclude with your answer whether it is a factor or not a factor. Okay, so this was the case 1 when the factor is given, and it was the pretty easier one. Okay, now we'll start with the second case, which talks about factor is not given. Okay, and as you can see on the screen, the question is factorize this polynomial. It doesn't talk about anything else, but it will just say factorize. You are not given any factor. You're just nothing, no zeros, nothing, but just the polynomial. Okay. I have written various steps so that it becomes easier for you also to recollect what needs to be done turn by turn. Okay. Now, with the first one, what we need to do over here is factors of the constant. The constant is 5. And when you have got a number as a constant over here, you need to take all the factors. And when we talk about factors, it is not going to be just positive factors, but we need to take into consideration the negative factors over here also. So the factors of 5, they are going to be positive negative 1 and positive negative 5. That's all. 5 is a prime number, so it has only these two factors, 1 and 5. And I have written positive negative in front of both because we want to explore both the options with positive as well as negative. Okay, this was your first step. Now the second step, hit and trial with the factors found. When I say hit and trial, it is with respect to the remainder theorem. Okay, now I'll start with the first factor, which is positive 1. And how do I start? If I take x equals to 1, that means x, what I need to do now, I need to substitute the value of 1 in the given polynomial, right? So that means px equals, I'll not waste the space over here, just a moment. So what we get over here is p of 1, and that leaves me with 1 cube minus 3 times 1 square minus 9 times 1 minus 5. The target is we should be having equated with 0 over here. If we get it 0, that means 1 is going to be a 0 of the polynomial, otherwise not. So what we get over here is 1 minus 3 minus 9 minus 5. And as we can see, the negatives are bigger. It is giving me 1 minus, we have got 12 and 5, that is 17. And that results in negative 17, which is not equal to 0. So therefore, 1 is not a 0 of this polynomial. Let's try with the next one, which is x equals negative 1. The process repeats. I'll substitute negative 1 now. So we have negative 1 cube minus 3 times negative 1 square minus 9 times negative 1 minus 5. So what do we get over here? Negative 1, negative 3 plus 9, negative 5. And if you calculate, this is coming out as 0, right? So now, what do we get? We get that x equals negative 1 is a 0. This means we have x plus 1 equals 0 as a factor. Now what we are doing, see, in remainder theorem, we had done that we were given a factor and we were equating with 0 to get a 0. Now over here, we have just moved in a slightly different manner. We first found the 0 by hit and try using the constant. And then when we got confirmed that yes, this number is a 0, we are forming a factor by transposing negative 1 to x. And that gives us the factor x plus 1 equals to 0. Okay. Now, the next step, divide with the selected factor. We have got x plus 1 as a factor. So now we need to divide, and this is log division. Okay. Now, what do we do in log division? Let's see step by step. We had seen that it was x plus 1. Okay. Now, first we need to divide the first term of your dividend over here, which is x cubed, with the first term of your divisor. And when you divide x cubed with x, what do you get? You get x squared. So this becomes your first term of the quotient, which we will be writing on the top. Okay. Now, if you multiply x with x squared, you will get x cubed. And we are going to write x cubed, the product, over here. Now, the next step is you need to times 1 with x squared. And that results in positive x squared. Because 1 was positive, x squared was positive, right? Now, after we have written x cubed plus x squared, we are going to subtract them. Subtract x cubed minus x cubed. So this cancels out. And then we have minus 3x squared minus x squared. So this results in minus 4x squared. Okay. The remaining terms will be copied down as it is. There will not be any change of sign, but they will be copied down as it is. So I will have minus 4x square minus 9x minus 5. Now, the whole process repeats like we are going to divide minus 4x square with the first term of the divisor, which was x, and this gives me minus 4x, and this is your second term of your quotient. And I write it on the top after x square as x square minus 4x. Now, the next step, you need to multiply x with minus 4x, and that results in minus 4x square. The next step, you need to times this one with negative 4x, and this results in minus 4x. After this, we are going to subtract. So when we subtract, the signs reverse. Okay, that means this negative will turn positive, and this negative will also turn positive. So now you have minus 4x square plus 4x square. It will cancel out. And now you have minus 9x plus 4x. This results in minus 5x. After that, this term is copied down, and what we get is minus 5 over here. Again, the whole process repeats. We are going to divide minus 5x with the first term of our divisor, which is x, and what we get is just negative 5, which gets noted down on top as the third term of our quotient. After this, you times x with negative 5, and what we get is negative 5x. Now, we times 1 with negative 5, and we have minus 5 over here. So now, subtraction reverses the signs over here. This gets cancelled, this gets cancelled, and what we are left over here is just 0. Okay, this is the process of log division. Okay, now we have got two factors so far. The first one was using the hit and trial and the remainder theorem, and the second after using log division, which is x square minus 4x minus 5. But this question doesn't end over here. When we are talking about factor theorem and we are not given any information, just the polynomial, and we are supposed to factorize, the question becomes longer if it is a cubic polynomial. And this was a cubic polynomial. It's a cubic polynomial. That means it has to have 3 linear factors. And so far, we have got just one linear factor, which is x plus 1. This is a quadratic expression, so we need to factorize it further. Okay, so now let's start with the further factorization of this one. So I'm just writing down the expression, the factors we have got: x square minus 4x minus 5. The first factor will be carried down as it is. We need to factorize the second one, and what we are going to do over here, we are going to split the middle term, because we can see there is not going to be any identity which is applicable over here. So when we factorize this, I am going to have x square minus x minus 5x minus 5, because the factors for 5 are just 1 and 5. So according to that, I have split the middle term, which was minus 4x. So now it results in grouping, right? I get over here x minus 1, minus 5 comes out. I'm left with x minus 1 once again. Now, x plus 1 was the first one. And what we have? X minus 5 over here. And the second as x minus 1. So now I am getting the final answer, which is x plus 1 times x minus 5 and x minus 1. So here we have got all the linear factors of the cubic polynomial we started with. So in this video, we have learned factor theorem, which is having two cases. If you are given the factor, you are just going to do it with the way as you do for remainder theorem. And the second case, when you are not having the factor, you do multiple steps. Start by factorizing the constant, then apply hit and try, followed by remainder theorem. There you will get your first factor, and after that, you need to do long division. Once you do long division, you will get a quadratic expression on the top if we had started with a cubic polynomial. So the quadratic quotient you have got, you need to split it further. And this resulted in all the linear factors. If you want me to make further videos on long division or any further details about this factor theorem, do comment and I will make the video. Bye.